Hello, hello. Hi, everybody, and welcome to this new session of Coffee Break with Eddyfi. Today is a new format. It's going to be two of us, so two for the price of one. Hi, Fernando.
Hi.
So today is going to be, instead of talking about a topic, we are here to answer your questions. So please start asking your questions. You have the comment section on your right-hand side. So you can start asking your questions. And in the meantime, I'm just going to introduce myself. So my name is Frédéric Reverdy. I'm here with Eddyfi Technologies in Paris with the M2M business unit. I'm a senior technical sales specialist. And my quick background, so I've been doing NDT for over 24 years, so quite some time. I finished my PhD on inspection of composites using laser ultrasonics back in 2000. Moved to the US for 5 years, dealing with a project on oil and gas and automotive. Spent 10 years at the Atomic Energy Commission here in France on phased array, EMATs, TOFT, TFN, which we will be talking about a little bit today. And I've been with Eddyfi for a little bit over 6 years, dealing more with sales, supporting the sales team and developing methods. So Fernando, hi again. And can you tell us a little bit about you?
So I'm Fernando. So I've been in the industry since about 2001. So I actually started repairing calibrating equipment as far as like UT equipment, eddy current equipment. And then, so I did that for like 6 years and then moved more into like a technical support role. So I did that for 5 years and then moved on to being an instructor in ultrasonics for 8 years. So I got my UT level 3 and ASNT back in 2012, restarted it in 2017, but I joined Eddyfi here in January this year.
New guy, newbie.
New guy, that's right. So I want to learn more about TFM and FMC. So it's definitely a good change.
All right. So while we are waiting for some questions, I'm just going to do a little bit of history. I'm going to share my screen about TFM. And here we go. All right. So a little bit about history. I would say like less technical. Just try to remember when it started. Up. Here we go. All right, so the history of TFM. So it's starting with post-processing. It's I guess now it's real time. We just tend to forget that it didn't start that way. And I would say the precursor of the TFM was probably the SAFT technique. So the synthetically aperture focusing technique back in 1986. And this is the computer we used at the time. So for those who are old enough, you remember the 386 series, nothing to do with our computers today. But at the time we used a conventional UT probe, move it along the surface of the transducer, recording the components, this is today, and recording data and post-processing on the computer within the region of interest. So it's very similar to TFM. Then you move back to 2005. That's probably the first paper on TFM for NDT from the University of Bristol. You have here the reference in case you want to look at it. And back then, the computers were a little bit faster than they were before. And you still had to record the data with a phased array system this time. So the full matrix capture data. And you transfer the data to a PC for post-processing. I just also want to mention our friends of CEA, because I spent 10 years over there, and Extend with SIVA, the simulation software that had the capability in 2009 to post-process data to calculate TFM with all the modes on complex component. And then we moved to 2013, which with the introduction by M2M at the time, of the first Gecko, which was the first PAUT system with real-time TFM capability. So that was kind of when we put the technology on the market. We introduced in 2017 another system, the Mantis, which is kind of more like a lightweight, smaller system with less capability in terms of TFM, but still interesting. 2019, the Panther, which is like a desktop unit more for laboratory and integrators. And we are here today, of course, still with the Panther and a revamp of the Mantis and the Gecko. So you see the evolution of our product at M2M Eddyfi. All right, so that was kind of a quick history of TFM. So let's see if we have a few questions. What type of probes do you suggest for TFM inspection? You want to take this one, Fernando?
Yes. So we'll try to work together on this one. So one of the things that from my experience so far is, so one of the things that we recommend is using at least a 32 element probe to take advantage of the full FMC TFM capabilities. So so we have some customers that you purchase 32 element pros, 64 element pros, 128 element pros. So of course you can use regular phase rate pros, so there's no special pros required.
Yeah, that's the beauty of it. Like our customers who already have, big sets of probes can use what they have. And I agree with you. We need to have a big aperture to focus the energy to take advantage of the TFM. Well, address the main application. Okay, well, the question is on the screen. Address the main application for TFM nowadays. I feel the technique is definitely getting used more and more. Yeah, that's correct. So I'm going to share again. Up. So I would say like the first industrial application that was using the TFM was the inspection of HTHA, high temperature hydrogen attack, which, to be honest, we didn't think about at M2M. But when you think about it, this is the perfect solution for it. If you look at, that's a macrography, and you look at the size of those defects, they're pretty tiny. So you really need to focus the energy to have this really good sensitivity. And here is the result actually for this mock-up here. We use a L0 probe, high frequency, and you can really see here all the echoes coming from the HTHA. This is a top view, a C-scan. You can see here the band of HTHA. And if you look at A-scan, you see kind of an increase in amplitude when you are in the HTHA region. I don't know, Fernando, have you used TFM for HTHA?
I have not yet. No.
All right. So,
but one of the things I have seen that, so customers have contacted us about using TFM for looking at cracking in the heat affected zone. So we have had good results with customers using TFM to look for those indications. Because sometimes what happens is people start using a larger aperture, using a phase rate probe, and sometimes the cracks come up and inside the near field, and maybe you can't see it on the actual screen, but you might be inspecting in the near field and you might not be able to pick up the cracks that are coming up. So we have had success with that.
Well, and I would say like the ideal applications, obviously like we can use TFM for a lot of applications, but is volumetric indications. When we are looking for very tiny indications, we really need to focus on that indication to have maximum sensitivity. But typically when we use high focus, being conventional or phased array, we have this high focus, so very small beam, but we tend to have a very small depth of field. So it becomes very, very sensitive to positioning. The advantage of TFM is we have this high focusing within a region of interest, and we are not sensitive to positioning. We have no depth of field problem. This is an application from a customer. This is the radiography. You can see a porosity. This is in a titanium component, mostly beta phase. So it is hard for ultrasound typically because the grain size is between 0.5 to 1 millimeter. And the porosity here is 0.65 millimeter. And if you look on the TFM here, you can really see the porosity. And if you look at the signal, even though we have some noise here, you can see the noise, we are still able to get this porosity. And recently, maybe you want to touch about that. We are using TFM for other applications. I don't know if you want to talk about it, Fernando, this weld corrosion.
So as far as the weld inspections, we can do multiple group inspections. So we can do different types of modes. So we have TT, TTT, 4T. So there's different types of modes that you can generate to see which one's going to give you the best results. So you can also use it for corrosion mapping, looking at laminations. So we have had a customer that had great results with the inspection looking for corrosion and using the TFM for that. So, and the customer was pretty happy with the results. So.
And I think I forgot one. There is another one that is obvious as well. That is hydrogen-induced cracking, or HIC. Obviously, the scale is much bigger compared to HTHA. But the advantage here is those are TFM, and this is linear scanning with a phased array, is to be able to detect the connection between the laminations you were talking about. Especially, for example, for this one, if we look at electronic scanning, we just see like a delamination in the middle of the components. This is the backhaul. But with TFM, because we send energy everywhere, we can actually see that this lamination is actually connected to the backhaul. So eventually, it's going to form a blister. I think that's it for some of the applications. But I mean, our customers are coming with all kinds of applications. So it's the beauty of having a technique. I'm giving you this one.
There we go. So which training do you recommend to start using TFM? So one of the requirements is to have at least a UT level 2. And then, so we typically recommend phase array. But so AS&T has already, or AS&T and ASME have already accepted FMC TFM in the 2019 code. So they actually recommend 80 hours of TFM training.
Yeah, and I think all our colleagues in the training schools who are using our equipment and other equipment are already providing these FMC TFM training courses. So
the courses are so they're a complete 80-hour course. So it's pretty much 2 weeks together.
Yep. All right.
So any size. So the next question is going to be any data file limitation size sometimes makes it so that we can't record in one time. That we need to keep it in mind. So the main question is as far as data file size.
Well, I would say file size is bigger on TFM. If you don't record even if you don't record the FMC, it is basically an image for each position. So the more pixels you have, the bigger the file size. Although like it is still manageable. I mean, it's maybe a little bit bigger than PAUT. The problem starts when you want to record the FMC data. So all the full matrix capture data. Remember when we use a 64-element probe, you fire 64 times, you receive 64 times each time. So you have a lot of data. Each frame that we use to calculate TFM can be about 30 megabytes. So you can imagine like if you get 30 megabytes every 1 millimeter, if you have like a 20-inch pipe, you could quickly have like 20 gigabyte file. So typically when we do TFM, we do like PAUT, we keep the image, the TFM image, and we record as we move.
Next question is, what do you see for the future regarding TFM/UT?
I guess give us your opinion, Fernando, since you are new to the technology. What do you think?
So as far as for me, so I see it. So I feel like FMC TFM. So it's been in the market a few years, right? So
yep.
But one of the things that has come along is the capability to do onboard the system without needing a computer. So I think that's where making it more portable is going to make it take off a lot faster. So one of the things I've seen is, like I said before, looking at cracking, looking at replacing radiography. That's another option. So I see a lot of interesting inspections being performed here in the future.
Yeah, I see. I agree with you. Like I see, like if we look at, I mean, our product evolution since 2013, like one thing we have tried to improve is speed, obviously, because when it started, it was only a couple of, I don't know, 20 millimeters per second, something like that. Try to make it compatible with today's applications. And today we are like obviously over 100 millimeters per second, more pixels. This is like having like a camera phone, like, you know, the first phones we had like back in the days, you were happy if you had 1 megapixel. And now like our phones like take like 8, 12 megapixels. So I think evolution is going to be more like toward more capabilities, more pixels, faster. And also, like I would say, like I'm going to share again my screen. If we look at, we have introduced, I think it was last year, Capture 3.1. Yeah, I think it was Capture 3.1. We have introduced like plane wave imaging, which is another way of doing TFM. Instead of firing the element one by one, you fire all the elements, doing like a sectoral scan like this. You don't use all the degrees like PAUT, and you do a TFM after. So you send like this big plane wave for a couple of degrees and do TFM. The advantage, of course, compared to FMC is you use the full aperture, so more energy, so better sensitivity, especially when you go deep, and faster. Because here, if you look, I don't know, we have 8 angles compared to 64 when we do FMC. So we can, in theory, go 8 times faster. Today, this is available on the Gecko and the Panther. And sometimes some of our customers are asking, like, but is this part of the code? And actually, if you look at the definition of FMC in ASME section 5, it is actually pretty general. This is not firing one element at a time. You can fire a group of elements. It can be all of them, like 5, whatever. So FMC defined by ASME is more general. So plane wave imaging is already falling into the code, and ISO is kind of the same.
So what I usually compare, so for those that are out there, so what I usually compare the PWI is, imagine like phased array, but with TFM.
Yeah.
Like a sectoral scan. So like a sectoral scan, but you're receiving with all the elements instead of just the aperture that you chose.
That's easy and quick definition, but a good one.
Yeah.
I don't know if we have other questions. Do you want to take it? You want me to
I'll let you take this one.
Oh, thank you. All right. So pros and cons of having TFM A-scan on display or not. Some systems cannot display them. Correct. So I think like probably most systems are now capable of doing it. I think at the beginning we are kind of the only one doing it. But TFM is obviously an image, but people want to have a signal, because when you're going to measure amplitudes, you need to have a signal to measure like a signal. The amplitude of a defect to see if it's a big defect or not. So there is obviously, for me, it's mandatory to have A-scans for TFM. And I will push it a little bit farther. That was probably not part of the question, but I would also say, like, when you do TFM inspection, especially when you do well inspection, I would recommend to do a TCG as well. So on your A-scan, when you look at the amplitude, you can refer that amplitude to your TCG level and reject or accept defects this way. The same way as PUT and UT.
So one of the things from my experience, so I saw TFM, I say about maybe 4 years ago. And at that time, there were some units in the market that actually just showed you the image as far as what we call the T-scan, which is a TFM, which is pretty much like a side view. And so you'd have the image, but you wouldn't have the actual A-scan that goes with it. And so somebody that's used to performing inspections with ultrasonics, like basic ultrasonics, maybe shear wave or phased array. So people are used to having the A-scan, and it's like, I can't do anything without the A-scan. So I think that's something that's come along. So most of the equipment on the market now has the A-scan with it.
Yeah, I think it's a natural way of things. Like competition is going to evolve, and it's good. I think competition is good for everybody.
Yeah.
So
what's the difference between TFM and phased array?
You take this one?
So the difference, so what I usually recommend, or at least, so the way I explain TFM is with TFM, you're pulsing with one element, and with phased array, you're pulsing with a group of elements. So you're sending with one element, receiving with all the elements, sending the second one, pulsing with the TFM, I mean. So pulsing with the second element, receiving with all of them, or you can use PWI, which is firing a group of elements at a time.
I would say like probably the main difference is the fact that we, instead of doing a sectoral scan or linear scan, we define a region of interest and we focus at every single pixel. So this focusing everywhere within a region of interest. That's probably the big advantage of TFM. You have optimum spatial resolution everywhere within your region of interest. When you do PAUT, sometimes people don't actually use focusing, but if you do focus, when you do a sectoral scan, you have to tell one depth or one sound pass or like projection if you use a line. So you have different focusing algorithms, but you have to specify where you want to focus. Now, with TFM, you don't. You just focus everywhere. Just put your area, and you're going to have high focusing capabilities. And I guess when you have been using TFM for 10 years, sometimes people tend to forget that the F is focusing, and you have this really good sensitivity on tip diffraction sometimes. When you look at cracks, like the tip, you actually get better sensitivity using TFM because of this high focus.
So one thing I've seen from the time that I've been here, so I've been here at Eddyfi for 6 months, right? So I've actually seen owner operators actually call out TFM. So a company comes in and does the inspection with phased array, and sometimes they do the inspection with the TFM, and they give the results comparing both of them. So the customer starts trusting more of the TFM side compared to the phased array. So it's like a slow transition. So it's almost like replacing shear wave with phased array. So I saw that maybe 5-10 years ago, where people start having like a hesitancy about switching to phased array because all they know for the past 20 years is shear wave. So that's one thing I've seen. So I don't think phased array is going to be replaced, but I think there's going to be a set transition over to TFM.
Yeah, I agree with that. I think like it's like TOFT, right? Or conventional UT, like people are still using those techniques. Sometimes they are sufficient. Right. So why use something more if you are satisfied? But this is just like another tool on your Swiss Army knife, right? You have UT, yeah. TOFT, phased array, TFM. So you have all these tools that you can use. All right, I'll take this one. So the Panther is our desktop unit. It goes from 32.128 to 128.128, meaning you can use the full 128 element. So you can do 128 element plane wave imaging, PAUT, FMC, and if you put two Panthers, you can do 256 element plane wave imaging and FMC as well. So the more Panthers, the more elements you can use. So, and obviously when you use such a large aperture, you can focus really, really, really far. But the limits in terms of focusing, it's still like the limit of diffraction. So like one wavelength. But I mean, using a full 128 elements is going to give you like good penetration, a lot of energy, and near field that is being pushed pretty far. So the answer is yes. All right.
So the question is, can you recommend a PAUT scanner for weld inspection?
I think we don't have the choice in saying this one.
So on our product line, we have a link scanner. So you can do corrosion mapping, or you can do dual-sided phased array inspection or TFM inspection. So
yeah, that's a good product from our colleagues from Silverwing in the UK. You can put up to 6 probes on it. So like a pair of PAUT and 2 pairs of TOFT, or you can combine even more PAUT if you want. So yeah, it can be used for, I think they just released it with a chain now. So if you are dealing with a stainless type weld, you can also use the chain scanner. And axial links is also coming up with for seam welds, so longitudinal weld. So it's kind of like they also call it the Swiss Army of scanners. They took it from us. But yes, this is actually a pretty cool scanner. You can just actually like dismantle it, and it's like a Lego, and you build a corrosion scanner and so on. Good scanner, but I mean, we are not limited to those scanners. So if our customers or future customers already have some scanners, they can use it with TFM without a problem.
So next question is going to be, can I make TFM on OD surface with correction surface?
I believe this is for, I guess, COD wedges, I guess. Yes, actually, yes. Both the Gecko, all our equipment, the Mantis, Gecko, and Panthers, can use COD wedges. So if you have a pipe and you have a longitudinal weld, you will need to use COD wedges with a shape. And the software, so Capture for the Mantis and Gecko, or Acquire for the Panther, are calculating the TFM images, taking into account the curvature. So you can do like your nice COD calibration, wedge delay calibration on both equipment. It will actually measure the angle and height, taking into account the curvature. You put your probe, calculate your TFM, taking into account the curvature, and even for direct mode, indirect modes, and you can see all the modes. So yes, you can actually use the TFM for this application. Well, I think I believe we have answered all the questions.
So I'm going to ask a question. So the main thing from my experience since I saw TFM 5 years ago approximately. So one of the things was the scan speed, right? So the scan speed, as far as like how fast can we scan?
Oh, that's a question for me. Sorry. Yeah, who else? As I said, like when we started, and that's probably when you actually saw the Gecko the first time. I saw your profile on LinkedIn a lot of time, and it was like 20-25 millimeters per second using a 64 element probe and 65,000 pixels. That's always a difficulty with TFM and speed when you look at different brands. So obviously Eddyfi and our competitors. You always have to check for the number of elements, the number of pixels when you give a scanning speed, because this is linear. If you use a 32 element probe or 64 element probe, you're going to go 2 times faster, 2 times slower, sorry. If you use 2 times more pixels, you should be 2 times slower. So also another thing that's really that impacts productivity and scanning speed is the architecture of your system. If you use a 64 element probe and your system is a 32 128, for example, or 3264, to calculate the 64 element TFM, because you only have 32 elements, it's going to have to fire twice. So right off the bat, you take a factor of 2 in terms of productivity. You lose a factor of 2. So you really have to pay attention to the architecture of your system. Although I would say like our 32 128 TFM 64 Gecko still has the same productivity than our 64 128. We did something. Our engineers did something like to not lose that speed actually. So, and if you use a Panther, the speed here, the limitation, you can use pretty much as many pixels as you want, because we transfer the data to a PC, and we use a graphic card to calculate the TFM. So hopefully with the Bitcoin and all the farming, we can have access to graphic cards again. But if you want to calculate like a 2 million pixels or 3 million pixels on a graphic card, that's something we can do. So here the limitation.
We have another question. Will Capture be able to merge upstream and downstream TFM data sets in the near future?
For example, seeing an indication one test come from both probes. So actually, like already, if you do TFM with 2 probes, so since Capture 3.2, which was released back in March, we can do multi-group, multi-mode. We can do TFM from both sides of the well, which is you have to do when you do well inspection, and you can actually merge the data in 3D. So you can merge the data from the 2 probes. Mm-hmm. Maybe John is asking if we have different files using the same probe. That's in the plan to be able to merge data from different files, not only for TFM and embed PAUT as well. So we try to every single version. So this year we had 3.2 in March. We're going to have 3.3 next month. So it's going to be a quick one, a smaller one, I would say. And we are going to have a 3.4, I think, for the ASNT in Phoenix in November. So you see, like 3 versions per year. And if you look, we have done some workshops on the 3.2. If you look at what there is in it, that a lot of stuff. So we try to listen to our customers. So John, hopefully one in the next versions, we can do that as well.
So as far as I want to add the scanning speed. So as far as, so one of the things that we can do, so you have TFM and you have PWI. One of the things that we can do to increase the scan speed is actually perform the inspection using the PWI.
Yep. Yep. We have to fire less times. So
Yeah.
Penguin Imaging is perfect for that. Thanks, Liana. Well, compliment. Thank you. So I think we are okay. Maybe like our colleagues can put our email address again on display. Yeah, here you go. I like this new stuff. It's pretty cool. So yeah, you have my email address. You have Fernando's. Please, if you have any questions, be free to send us some emails or to contact us on LinkedIn as well. Especially if you want some demos, we are more than happy to give you demos. Hopefully soon we are going to be able to travel again and have a normal life. So that was this new coffee break. Thank you guys in Quebec for organizing it. And I think we'll see you next time.
All right.